Okay, so Newton's second law, which is the law of force and acceleration, says that the acceleration of an object depends on the mass of the object and the amount of force applied. Y'all saw this yesterday, and that should make sense. How fast an object accelerates, how much it accelerates, would depend on the mass, first off. If you're pushing an elephant versus if you're pushing a dog, they're going to accelerate differently because they have different masses. And it's also going to depend on how much force is applied. If you barely push a ball, it's going to barely roll. If you push it with a large force, it's going to roll more. So those are the two things that force depends, or that acceleration depends on. And we represent that in this formula, which says force equals mass times acceleration. So today we're going to take notes on this formula. The good news is y'all already used the triangle for speed. We're going to use a triangle for this as well. So it's going to be easy peasy. All right, so there you go. Let's start by labeling what each of these letters means. Even though I'm pretty sure y'all know. The F stands for force. We measure force in newtons. The M stands for mass. We measure mass in kilograms or grams, either one. Make sure it's focused. And the A stands for acceleration. Which we measure in meters per second squared. Acceleration could be in kilometers per second squared, kilometers per hour squared, but we know we have a distance and a time squared. So our triangle is going to look like this. F on top, because we need mass times acceleration. So we have to put M and A on the bottom. On the STAR test, you won't be given the triangle, you'll be given the formula. So you have to know how to turn the formula into the triangle. You can memorize it, or you can recognize that in order to have mass times acceleration, they need to go on the bottom, because whatever is side by side on the bottom gets multiplied, whatever is on the top gets divided. Okay, so let's talk about the relationship between force, mass, and acceleration real quick before we use the formula. If we have a large force, meaning you push an object with a big force, and that object has a big mass. So a large force and a large mass. So imagine trying to push something really heavy. You apply a lot of force, but the object is really heavy. Is that object going to have a large acceleration or a small acceleration? So think about you're at the grocery store and you are, I don't know, maybe it's payday and your mom, or maybe it's the day before Thanksgiving. I don't know. Your mom is buying everything in the store. Like sometimes this happens when I go to Sam's Club or Costco and I haven't been for a long time, and their cart is so full and it is heavy. So it has a large mass. You push it with as hard as you can, big force. Is it going to accelerate a lot and fly down the aisle, or is it going to accelerate a little? It would just be a little. So we're going to put a little a. If you have a big force and a little mass, so now you're pushing with a lot of force, but you're pushing an almost empty shopping cart instead of a heavy one. It's a very small mass. Is it going to accelerate a lot or a little? Big force, small mass, so a lot of force on a very light shopping cart is going to fly down the aisle. So we're going to put a big A. for a large acceleration. Okay, one more. If we have a little force and a big mass, so if you have something really heavy like that really heavy shopping cart, and now you only apply a small amount of force, like your little sibling who is not very strong tries to push the shopping cart, it's going to have a big or small acceleration. If something's really heavy and you apply a really small force, it's going to have a really small acceleration. So I just wanted to review that from yesterday and keep those relationships in mind. All right, now let's do some examples with the formula. So our first example is going to be when we are solving for force. So if the problem is asking us, what is the force? All right, and I'm sorry, this is going to be a little bit of writing because we have to write the problems. We don't really have a choice. So we're going to write an example. What is the force on a 1,000 kilogram car that accelerates 8 meters per second squared? Okay, so it says, what is the force? So we are looking for force. We are given the mass. I know that's mass because it says kilograms. So the reason I know that is mass is because the unit is kilograms. And I wrote up here that mass is in kilograms. It can also be in grams. And it tells me that it accelerates at 8 meters per second squared. So of course that's my acceleration. So I draw the triangle. I'm looking for force. I'm given the mass of 1,000 and the acceleration of 8. If those two numbers are side by side, do you multiply or divide? Check your triangle up here. If they're side by side, you multiply. So what is 8 times 1,000? 8,000 newtons. So if you're solving for force, you're just multiplying. Easy peasy, you have a calculator. So y'all got that. All right. Example number 2. Is going to be if we are solving for mass or acceleration. So if we're solving for M or A. All right, so if we're solving for M or A, this is going to be different because we're not going to be multiplying. So we'll have to divide if we're solving for M or A. Our example is going to be a dog has a mass of 175 kg. What is the acceleration of the dog if a force of 15 newtons is applied? All right. So what are we looking for here? What is it asking us for? It says, what is the acceleration? So you're looking for acceleration. What are you given? Mass of 175 kilograms, force of 15 newtons. So this one is really nice because it told you this is your mass, this is your force. It might not always say mass of. It might say the 175 kilogram dog. You have to know that that's mass. It might say 15 newtons is applied. You have to know that is force. All right, so we always draw our triangle first. So I do expect y'all to have paper out when you do your practice today and draw the triangle. If you were in class, I would make you have paper out and draw the triangle. I would not let you do this without drawing the triangle on paper. And the reason is not to be mean at all. The reason is because drawing the triangle keeps you from making careless mistakes. Some of y'all don't need it, you think. Some of you don't want to write it, but it's not worth making a careless mistake. Write it, get good at it, avoid making a careless mistake. All right, so in this one, we're looking for acceleration. So I'm putting the letter A in my triangle. We are given the mass of 175. Mass goes at the bottom, so I'm putting 175 there. And force is 15, so I'm putting 15 there. If they are on the top and bottom, we divide. What number are you plugging in the calculator first? 15 or 175? I know what number y'all want to plug in the calculator first. Y'all want to plug 175 because it's bigger. But 15 is on top. So 15 goes in the calculator first. It's okay to get a decimal. The number that's on top goes in the calculator first. So when you plug that in the calculator, you will get 0.086, and we're going to say meters per second squared. All right, one more example. And this type is quite different. Well, not quite different, but now we're going to do an example of a two-step problem. So they like to ask ones like this on STAR Test, and honestly, these are easy questions. These are freebie questions. You just have to remember the steps. So y'all got this. The question is, what is the acceleration of the 7 kilogram box? So two-step problems have a question that generally only have one number in the question. So it only gave us the mass. It's asking for the acceleration, and that's because you're going to find the force from the picture that comes with the question. So this time we're going to draw a box. With a force of 97 newtons pushing to the left and a force of 125 newtons pushing to the right. So it's two-step because you only get one number in the problem, and then you have a picture. You can get force from this picture. You can get your other number. So let me back up. What are we looking for? We're looking for acceleration. So if we're looking for acceleration and we're given the mass, we know that the force has to be given to us. You can't find acceleration without mass and force. It's given to us in the picture. So when you have these types of problems, step one is find the force. How are we going to find the force from this picture? Well, these forces are going opposite directions. So are they working together? No, they are not. They are working against each other. So are we going to add or subtract? We're going to subtract. So 125 minus 97 gives us a force of 28 newtons. Okay, so I'm going to underline that because now we've found our force. You got it. Easy peasy. So then step 2, you should already know what to do. Solve for acceleration. So if we're solving for acceleration, we need our triangle. Solving for acceleration, we were given a mass of 7. We found a force of 28. If your numbers are on top and bottom, then you will divide. So what is 28 divided by 7? 4 meters per second squared. All right, so to summarize, most of the time, you will, not most of the time, if you are solving for F, M, or A, you use the triangle. Always. You always use the triangle. Y'all have done a triangle before, so that is easy. Same type of triangle as speed equals distance divided by time. Multiply if they're side by side, divide if they're on top of each other. The only place this gets a little bit tricky is if they only give you one number in the problem and they give you a picture. You have to recognize that you can get your force from this picture. No one is going to come to you on the test and say, find your force right there. You have to look at that and say, I can find my force right there. Find your force, solve for acceleration. And that is how you use the triangle. So y'all are going to have a practice today. And I would highly suggest that you get a piece of paper and you draw the triangle for each one for today so that you make sure you don't make any careless mistakes, because I want you to get a 100 on that practice. So if you do not get a 100 on that practice, I want you to use your second attempt. If you would have attended Zoom, you would not be watching this video because we would have done this together. Next time, attend Zoom so we can do these notes together and you can ask any questions you have.